it's Sarah. I'm back with another video in my calculus series. We are doing the last limits video before we move on to derivatives, and today we're talking about limits involving infinity. So first we're going to look at limits that go to infinity or to negative infinity. So looking at this graph, right, clearly from the left of 0 and from the right of 0, we are going towards infinity, right? We have an asymptote there. So the limit of this function is infinity. Let's see how we actually figure this out. We have to break this down into left and right limits. So the limit from the left, what we do is we actually plug in 0 from the left in here and square it. Now think of 0 from the left as just like a negative number really, really close to 0, whereas 0 from the right is a positive number really, really close to 0. If we square a negative number, we get a positive number. So this becomes 1 over 0 from the right. Now, over here, we have 1 over 0 from the right squared. If you square a positive number, you get a positive number. So this is also 1 over 0 from the right. Now, basically, when we have a limit that ends up having like 1 over 0, or any constant over 0, it basically means that the numerator is growing faster than the denominator, much faster than the denominator. And what that means is that our limit is going to be either positive or negative infinity, depending on the signs of the constant and the 0. Here, our constant is positive, it's 1, and our 0 is coming from the right. It's positive 0, basically. And so we're going to have positive infinity for both the left and right limit, and since those match, the two-sided limit is also infinity. Now, this problem's a little bit different. We can see just looking at the graph, as we approach 0 from the left, we're going towards negative infinity, and as we approach 0 from the right, we're going towards positive infinity. And so let's break this down into left and right limits in terms of how we actually compute it. So from the left, when we plug in 0 from the left, we have 1 over 0 from the left. And so again, we have a constant over 0 that's going to give us plus or minus infinity. And because it's 0 from the left, this is going to give us negative infinity. Over here, we have 1 over 0 from the right, which, as we saw above, is positive infinity. So we have different limits from the left and from the right, so the two-sided limit does not exist. All right, now we're going to move on to limits approaching infinity. So we have this principle here that the limits approaching infinity or negative infinity of a constant over some power of infinity is going to equal 0. Basically, infinity to the nth power is still infinity, because infinity times infinity is infinity. Infinity times itself n times is going to be infinity. So, sort of like how a constant over 0 is infinity, a constant over infinity is 0. So, in an actual limit, what we can do, like with this rational function here, is what we're going to do is take the highest power in the rational function, which here is x squared. We're going to multiply over 1 over x squared over 1 over x squared. And so now what we have is 1 over 1 plus 1 over x squared. Now let's plug in infinity to that. Infinity squared is infinity, so we have this. Like I said, 1 over infinity is 0. So this just becomes 1. Now, this problem is very similar, except here we have a square root of x to the 4th power. It's tempting to look at this and say, well, our highest power in the rational function is x to the 4th power, but it's the square root of that, which is x squared. So x squared is still our highest power. So that's what we multiply by, 1 over x squared over itself. And so here is what we're going to get. Basically, when we multiply the numerator by 1 over x squared, it's sort of like multiplying under the square root sign by 1 over x to the 4th, okay? So we end up with this. Now, if we plug in infinity, we have 1 over the square root of 1 plus 1 over infinity to the fourth. Infinity to the fourth is just infinity. 1 over infinity is 0, so this is 1 over the square root of 1 plus 0, which is, again, 1. All right, and finally, we're going to do a limit going to negative infinity. So this can be a little bit more complicated. So if the highest power in our rational function is an even power, then this works exactly the same as it does with positive infinity, okay? But here, we multiply by 1 over x over itself. That's an odd power, right? X to the first power. It's an odd power. So we have to stick a negative sign outside when we multiply this. So what's going to happen here, I'm going to pull the negative sign out. We have 1 over, and again here, this is the same as multiplying by square root 1 over x squared. This is going to give us 4 plus x over x squared is 1 over x plus 1 over x squared. So then this is negative limit, actually I'm going to go ahead and plug it in. So negative 1 over square root 4 plus 1 over negative infinity plus 1 over negative infinity squared is positive infinity. So what we get here, 1 over negative infinity and 1 over infinity, those are both 0. So we have negative 1 over square root of 4. That becomes negative 1/2. Again, if we had been multiplying by like 1 over x squared here or 1 over x to the fourth, we wouldn't have needed to include this negative sign. But because this was an odd power of x, we do have to include that negative sign. All right, if you enjoyed this video, please like and subscribe. Thanks, y'all.